Assalamualaikum warahmatullahi wabarakatuh. My name is Azif Khan bin Aslim Khan. My matrix number is 205537 and I am from team 2. And today our group will be presenting about the first assignment, assignment 1, about the differential equation. So what is a differential equation? A differential equation is a mathematical expression that connects one or more functions and their derivatives. In most applications, functions represent the physical values, whereas derivatives indicate their rate of change, and the differential equations describe a link between the both. So today in this report, we will see how differential equations is used in various types of fields, especially biology, chemistry, and also physics. As we get in deeper, we will understand why differential equations play so much role to give this such a huge impact in solving problems in application of real life. Okay, so I'll be presenting about the biology, which is the population growth using the differential equation. So, so in this section, we'll look at how a simple differential equation emerges when looking at the phenomenon of population growth. So here, N represents the number of individuals of a population. So the rate of change of N depends on the number of births, which increases the number of population, and the number of deaths, which decreases the number of population. So there we have the equation, rate of change of N equals to birth rate minus death rate. Next, we have R and M, which represents the average per capita birth rate and per capita mortality rate. So the R equals to number of birth rate per year over the population size, and M equals to number of deaths per year over the population size. So the total number of births in the population in year T is given as Rn, whereas the total number of deaths in the population in year T is Mn. So the rate of change of n is given by the derivative dn over dt equals to Rn minus Mn. So this equation can be further simplified, where R minus M equals to K, which represents the net growth rate. So there we have the equation which satisfies the differential equation dn over dt equals to Kn. Okay, now the general solution of dn over dt equals to this equation here, which is also known as the law of growth or the Malthusian equation. Okay, the n naught here represents the initial solution. There we have an example of graph of the population growth, which grows exponentially. Okay, here's an example. Let's say the population of a specific town A is 100,000 and the value of R is 1,000 and M is 500. Now, substituting these values in the equation will give us the rate of change of population, which is 0.5%. This means that the population of town A grows by 0.5% every single year. That's it from me. Thank you.
Assalamualaikum. My name is Ahmad Amir Akib bin Ahmad Jasron. My matrix number is 207449. So for the first math assignment, I will be the one covering the chemistry field, which focusing on radioactive decay. Firstly, for such stream student must be familiar with this equation, which is the differential of radioactive decay law. So the equation below shows the formula of radioactive decay in chemistry, where N is the amount of a radioactive material is a positive constant, but it depends on the radioactive substance itself. The negative sign in the right-hand side of the equation shows the amount of radioactive material, which is N in the bracket of T decrease over time. Looking at the graph below the equation, it shows the graph from the equation of radioactive decay itself. And if we look carefully to the graph, it was already in form of n in bracket of t equals to c exponent minus lambda t. So after that, in order for we to have initial value, we must determine the value of constant c. From the radioactive decay law, we can introduce two useful parameters as our next step. The half-life of a radioactive materials is the time required to decay to 1/2 of the initial value. Let's say if we have one and the one half is 0.5. Therefore, at the moment, our t going to be this equation. So moving on to the next slide. This equation shows step by step in order to obtain the half-life, the overall formula. And meanwhile, the average lifetime tau of a radioactive atom is known as tau equals to 1 over lambda. Looking back real quick at our last formula of t equals 1 over lambda ln 2, and this formula is related to the average lifetime. Hence, t is equals to tau ln 2 and roughly around 0.693 tau. So last slide. To have more eye openings in this topic, let's take a look of this example. So in this example, we have 10 grams of barium 139. It will decay within 86 minutes and turn into another form, which is lanthanum 139, which means we have 5 grams of barium 139 and 5 grams of lanthanum 139, because 10 the half of 10 is 5. Thus, roughly, we will have 10 grams of lanthanum 139 in 688 minutes. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iman bin Ahmad, matrix number 205901, and I will be explaining the principle and application of differential equation in physics. So, considering Newton's second law in physics, force is the product of mass, m, time acceleration. So F equals to ma, whereas the acceleration is the time derivative of velocity. So acceleration a is equals to derivation of velocity over time, and the velocity is the time derivative of displacement that denoted as x. Velocity v equals to derivative of x over time. Hence, the acceleration is the second derivative of velocity. A equals to the second derivative of displacement over time. So if we use back acceleration into the force equation, F equals to ma, so m times the second derivative of velocity. Now the application in somewhere in physics problem. Now we have an image over here. A block of mass is attached to a spring. Now, if the block of mass is pulled right out from the spring, so the force will be exerted on the spring as the spring wants to go back to its original shape. So a block with a constant mass is attached to a spring. When a block is pulled right out, a force will be exerted to the spring, and the derivative of the velocity with respect to time is acceleration. So that is why F equals to mass time acceleration. According to Hooke's law, force is equal to Fk equals to negative kx, and k over here is the spring constant, and because of the block is on top of a plane, and we know every object that is touching with each other will always create a friction. So Fb equals to negative b times velocity. So b over here is the constant of friction. So hence the total of force is equal to F equals to Hooke's law equation plus the friction equation, and we get negative kx minus bv velocity times equals to mass time acceleration. So now we change this into equal to 0. So we know that mass time acceleration, the second derivative of velocity times b is velocity. The derivative of displacement over time, and kx. X is just displacement. The final equation contains the second derivative, first derivative, and zeroth derivative, using y equals to y x, a general form of mathematical study of physics. Px times second derivative of x plus qx times first derivative of x plus rx, and zeroth derivative equals to 0. Now this is the equation that we have, the equation that has been shown just now. So hence, mass times second derivative of velocity is a second derivative, b is a first derivative, and kx is a zeroth derivative. This application cover the time independent Schrödinger equation, which is a second order differential equation. As a conclusion, based on all the topic that we have learned just now, we know the importance of existence of differential equation based on biology, chemistry, and physics. And we all know the differential equation are used extensively in research and engineering application. So after learning all the study, and at the end of this topic, we can enhance our understanding on this topic after studying various disciplines of this topic. Thank you.